In this video, we're going to look briefly at F distributions. So F distributions are similar to chi-square distributions that we'd studied in the previous section. It's a family of distributions which are all following, which have the following PDF characteristics if the degrees of freedom are both greater than 2. So it's defined only for positive values for the input, so it's 0 otherwise. This is like a chi-square. Like the chi-square, they start at the origin and increase to a max and then decrease. And they have a horizontal asymptote of y equals 0 on the right, and so they're skewed to the right. That basically, they look more or less like the chi-squares do. But this time, instead of having one parameter called the degree of freedom, there are 2 degrees of freedom that you have to keep up with for this. They're called degrees of freedom 1 and degrees of freedom 2. Or sometimes they're called degrees of freedom numerator, degrees of freedom denominator. Degrees of freedom are usually natural numbers, and there's one distribution for every pair of degrees of freedom. So here's a graph of a PDF for an F distribution with degrees of freedom 20 and 25. So this should say F PDF X 20 25, and there's a graph. Here's the window that I happen to use on this particular one. Here's the same graph on an Inspire, which is a better looking. Actually, the Inspire even actually makes it 0 over here. So it's actually 0 over here, goes through the origin, then comes up, maxes out, comes back down, levels out to the x-axis. Of course, the total area under that curve is 1, as it is with any PDF graph. So if we could use the PDF for an F distribution with these degrees of freedom, 20 and 25, to compute the probability that F is between 1 and 2, that is, that the x value on that graph is between 1 and 2. So one way we could do it is to graph it and then do the integral thing, which is the Calc 7, and then do lower limit 1 and upper limit 2 and get it to shade it. But there is a shortcut on the TI-84 at least, and that is go to draw under distributions. So go second variables, VARS, second varies, gives you distribution, right arrow to draw, and there is a shade F. And give it lower, upper degrees of freedom for the numerator, degrees of freedom for the denominator, draw, and it will shade that in. So nice little shortcut there. If you want to see the shading, of course, normally you don't really need to see the shading, or you might just do some shading by hand that's kind of a rough estimate without having to be very accurate with it, just so that you have an idea of what it looks like. But the actual calculations you can do on your calculator. Let's go ahead and graph the CDF, though. If we want to graph the CDF for F distribution, again, degrees of freedom 20 and 25, that's F CDF. Remember, it starts at 0, so it's 0 to X, 20, 25. Here's a decent window. And notice it comes in kind of curved up this way a little bit from the origin, going up, levels out at y equals 1. Here's a graph of the PDF and the CDF together on the with the TI Inspire, a little bit better looking graph. Okay. Okay, and this one has a graph where it is controlled by sliders here. I'll show you the actual thing that this came from in just a second. And on this one, we actually have a pretty nice formula for the mean. It's degrees of freedom denominator over degrees of freedom denominator minus 2. And that's represented by this light blue line right here. And so the mean in this one, let's see, I've got degrees of numerator, degrees of freedom, the numerator is 16, degrees of freedom, denominator 9, or DF1 is 16, DF2 is 9. And so we get this right here, 1.2857 is what's produced by this formula, and there's the corresponding y. Of course, notice that is bigger than a half, so that it is to the right of the median. To find the median, I'd graph y equals 0.5, which is this horizontal line here. You can see the formula for it there. And where that crosses and comes down, that x value right there is the median. Okay, and you can see that the mode is right here at the highest point, which is even further to the left. So they're in the order mode, then median, then mean in increasing order, just like they are for the chi-square distributions, and just like they are for any distribution that, or at least the median's less than the mean, is definitely true for any distributions that skew to the right, and this one has a mode that's even further to the left there. Okay, let me show you this. Yeah, here we go. So I can see what happens is if I change the degrees of freedom of the denominator. Now, when you get really small, let's see which one's x equals 1, 2. Once you get 1 and 2, some things kind of change kind of weird there, but once you get at least up to 3 for the degrees of freedom in the numerator, then you get a basic setup there that's fine. Okay. And those have that same basic shape as you see there. So you can kind of see what happens is if I change these around a little bit, what's happening here. So it looks like our standard deviation is getting a little smaller as we go out here, getting a little bit less that way. That one's a little bit harder to see exactly what's happening there. It looks like we're median switching a little bit. This one's going to move the mean. So as we go further to the right, it looks like the mean's getting smaller, getting closer to the median, and getting kind of further out here. Okay, so you can kind of see how that affects the graph of the CDF and the PDF a little bit as we change those two different degrees of freedom. And of course you see the skewness there and that as well. Okay, continuing on, use the graph of the CDF for an F distribution with degrees of freedom 2025 to compute and illustrate the probability that F is less than 2. Of course, that's just an X value of X is 2. And we probably that X is less than that, the output is the Y value. So X is 2, there's the Y value, I just did a trace. Type in 2, there it is there. Of course, from the home screen, you can just, if this is in Y2 as a CDF, you can just do Y2 of 2 at the home screen. Or, of course, you can just type it in this way, it's probably the way I would do it. F CDF 1, 2, 20, 25, and there's your probability. That's exactly the way I would do it on the calculator, whether that's the 84 there or the Inspire here. So basically, once again, it works just like the chi-squared one that we did several examples of in the last video. You just give it lower and upper, and then you give it the parameters. In fact, all of these, the normal, t, chi-square, f, they all basically work the same way. For the CDFs, you give a lower and then an upper. Then you have to tell the identifying factor, the identifying numbers for that distribution. For t and chi-square, that was one number, which was the degree of freedom. For the normal, that was 2 numbers, a mean and a standard deviation. And for the f, it's 2 numbers. The first one we call degrees freedom numerator, second one degrees freedom of the denominator. But either way, you just got to remember to put those in order, and boom, there is the probability. For this unit, I will be telling you the degrees of freedom that you're going to need for the chi-squares, the f's, and the t's. Later on, we may need to figure out what those are in context to some other problems later on, next unit. For an F distribution with degrees of freedom 20 and 25, compute B, where the probability that F is less than B is 0.99. Since it's an F distribution, I'm calling the X value F instead of X this time. Same thing. Well, you may notice when you pull up your TI-84, you got a nice inverse normal, you got a nice inverse T, but you do not have an inverse chi-square and you do not have an inverse F. So the only way to do inverse functions here is inverse probabilities is you're going to have to graph the CDF on a horizontal line and calculate the intersection. And we've done problems like this before, so this shouldn't be too much of a problem for us. We just put in FCDF from 0 to X, give it the 2 degrees of freedom in order, 20 and 25. The cumulative probability is 0.99. That's the probability to the left. That's going to be a line way up here up top. Find where the two cross by doing a calc intersection. You got 2.699. And we get that. And these are not comparing. Okay, it's because it says 24 is 25. Let me fix that. Okay, there it is with the right numbers now on the home screen of the TI Inspire. And TI Inspire has an inverse F, so it's a lot easier to do on that one. You just type it in like you do the inverse T or the inverse normal. You give it the left probability. You just got to pass it those 2 degrees of freedom as well, and you get the same number that you got the other way. Okay, so this should, by this point, after working through this, you should be able to be comfortable with the continuous distributions that are built in your calculator. That's the normal, T, chi-square, and F. Those 4 are very important for working with inferential statistics in our next unit. So be sure that you're good with computations with those 4 types of distributions. Basically, it boils down to you use the CDF to find probabilities. You use the inverse function to find inverse probabilities if you have it. On the TI-84, you only have it for the T and the normal, so you have to graph the CDF and a horizontal line and calculate the intersection for inverse probabilities when you're doing the chi-square and the F. When you're doing these calculations on a TI Inspire, they have inverses for all 4, so it's a little bit easier there. Okay. The only reason you'd actually need the PDF graphs is if you're trying to graph the curve, the PDF, and doing some shading or something for some areas, which you can do if you want. It can be pretty helpful sometimes, but it's not absolutely necessary as far as computing numbers.